morning. Welcome back. So last class we started with we finished creation of a linked list and then we started with inserting a node in a linked list. So inserting a node is nothing but you already have a linked list and you're going to insert a node, like you have created a new node and then you're going to insert it. What is a node? Linked list is a collection of nodes. That is, data is stored in the node. And then a node has two parts. One is the information part and the other one is the link part. So in the information part, you need to declare the structure of it, like how would be the node. Actually, the structure of the node has to be declared before. And since they are not continuous memory locations, they are scattered throughout memory. Since the dynamic allocation, that is, nodes are created dynamically during runtime and they can also be deallocated or deleted during runtime so that memory can be utilized by any other programming element. So we started with inserting a node in a linked list. A node can be inserted at the beginning of the list. That is, you already have a list and suppose you created a new node and you want it to be the first node. How do I say it's a first node? Because head is a pointer which would be pointing to the first node in the list and the last node, link part of the last node would be pointing to null. So the link part of the other nodes would be pointing to the next node in the list. So the traversal in a single linked list would be from the first node to the last node. You cannot traverse in reverse direction. Getting it? So we started with inserting a node at the beginning of the list. I wrote the algorithm, then explanation as well as the code module for that. Now we will start with insertion of a node at the end of the list. After that we will be doing insertion of a node at a given position. Once all the three is done, I will give you separate code modules for each and then I will show you the one program wherein the user can choose where he wants to. First you need to create a linked list. After that you can choose where you want to insert the node, whether it is in the beginning of the list or the end of the list or at a given position. So creation of a linked list is a practical program. All these are not practical programs. We'll start with insertion of a node at a end of the list, then we will do at the given position. I'll start with the algorithm and according to the algorithm I'll explain you with the diagram and then we will write the code module for the same. So please note down inserting a node at the end of the list. Please make a note of the algorithm statement. Let list be a list stored in memory and I would request you to note it down along with me so that it is easy and will not be wasting time. So I don't want complaints that you need more time to write, because anyway I'm typing it out, you are more faster than me, you can write it down. Let list be a list stored in memory. Head gives the address head gives the address of the first node this algorithm inserts item into the list as the last node. Current pointer is a pointer which is pointing to the current node of the list. So let list be a list stored in memory. So list is a linked list which is already stored in memory. So head gives the address. We know that head gives the address of the first node. Head pointer points to a node, and then the one to which it is pointing to would be the first node in the list. This algorithm inserts an item. Item is nothing but a node, because normally you insert an element into the list with the help of a node. You dynamically create, then insert the information part, wherein you would have whatever element, information element you need to insert into the list as the last node. That is, whatever node, the new node you are creating, that would be the last node in the list, which is pointing to the current pointer. Is a pointer which is pointing to the current node, because current pointer is used for traversal, and you would be traversing the list with the help of the current pointer. So current pointer is a pointer which points to the current node in the list. I will tell you what exactly that means once we proceed with the algorithm. Please note, make a note of the statement of the algorithm. Step 1. So what is step 1? First you need to create a node and store its address in the pointer new node. That is there. Okay. Create a new node and store its address in the pointer. Store pointer. So yeah, first you need to create a node. That is what we have done, a new node, and store its address in the pointer new node. Is equal to new node is equal to what? Address of the new node. After that, step 2, what I need to do? After this, I need to copy the information for the new node to the information part. Copy the information of the new node to the information part. So what you have to do, you have to copy the information of the new node to the information part of it. Then how will I do that? That is info of new node is equal to element. And where will you get this element? It would be passed from the calling function during the function call. I would be doing that. Step 3, what I will do, make the link part point to null. Set the contents of the link part point to null, right? Set the contents of the link part to null. Set the link so you need to make the link part point to null, right? Link of new node is equal to null. Then that is what I did. First I created a new node dynamically and inserted the information part as well as the link part. I made it point to null. After that, what you have to do, because since you are going to attach it as the last node in the list, you need to traverse the linked list using the current pointer, because you don't know how many nodes are there in the list. You need to start from the first node and you need to traverse the list until you reach the last node, because the last node would be pointing to null. The link part of the last node would be pointing to null. Since you want to make this new node as the last node, you need to make the last node point to the new node, so that automatically the new node becomes the last node in the list. So I'll just explain it that way also. Like I'll go through the algorithm and I'll show you according to the picture how does it work. According to the diagram, how do you traverse for each step or the each iteration of the loop. So what I will do, initialize head value to current pointer. Step for initialize head value to current pointer. Head to, we can directly initialize because both are pointers, right? So whatever RHS gets substituted to LHS. Step 5, find the last node of the list. That is what I have to do. First, I should make the current pointer point to first node and then I need to find the last node of the list. Find the last node of the. How will I do that? I will traverse the list until the link of the current pointer is not null, because once the link of the current pointer becomes null, it means that it is the last node, because the link of the last node is null, right? While link of current pointer is not equal to null. What you have to do? You have to traverse the list, right? I'm going to traverse the list until the link of current pointer is not null. So until the link of current pointer is not null, I'm going to traverse the list. Once the current pointer's link becomes null, what I'm going to do? I'm going to stop traversing, because I would have reached the last node in the list. What would be step 6? Move the current pointer to the next node, right? How will I do that? How will I move the current pointer to the next node? Current pointer is nothing but link of the current pointer. current pointer is nothing but link of current pointer, and then I will end my while. Because once it comes out, I don't have to, once what is that, null, that is link where it points to null is encountered, I will come out because I would have reached the last node in the list. After that, what I have to do, I have to connect the new node to the link of the last node, right? Then only it gets connected to the linked list. Connect the new node to the link of the last node. So, how will I do that? I will say link of current pointer is equal to, anyway I have set the new node's link to null, so automatically the last node in the list becomes null because new node's link part I have already set it to null, right? Then exit. This is your algorithm. We'll just go through that again. So, what does the algorithm do? This algorithm attaches or inserts an element or inserts a node into a list as the last node of the list. Last class we did first node. In this class we'll be doing the last node. First, what I have to do, the step 1, first I need to create a node. That is, first I will create a pointer new node, and dynamically using new I will allocate memory to the new node. Depending on what is the structure of the node, that many bytes of memory would be allocated, and new node is a pointer which would be pointing to that memory location. So, new node would point to the address of the new node, and then copy the information of the new node. So, first you need to ask, that is, I will be asking the user to enter the information part, and then I will pass it as an argument, and the information part of the new node, that is info, is the information, that is a variable which will hold the information part of the new node and is equal to element, whatever you want to store, and then set the contents of the link part to null, because node has two parts. One is the information part, the other one is the link part. So, the link part I am making it point to null, and then I am going to ask the user to enter the information part. I am going to store it in the information part of the node. After that, I am going to set the contents of the link part to null. So, this is the link of new node is equal to null. That is what I am going to do. After that, since I need to add it as the last node. So, the last node at the present existing list will be pointing to null. So, that one, instead of pointing to null, should point to the new node. Then only the new node would become the last node in the list. So, what I have to do, I need to traverse the linked list. Starting from the first node, I need to move through all the nodes until I reach the last node. How will I know it is the last node? Because the link part of the last node would be null. So, initialize head to current pointer, because head is a pointer which points to the first node of the list. So, that is how I will know which is the first node. Current pointer is equal to head. Find the last node in the list. How do you do that? You need to make the current pointer go on traversing from first node to the second, to the third, to the fourth, until the current pointer is pointing to the last node of the list. So, while the link of the current pointer is not equal to null, because once the link of the current pointer becomes null, it means that you have reached the last node in the list. You move the current pointer to the next node. Current pointer is equal to link of current pointer, and while. Then after that, connect the new node to the list. That is, the link of current pointer when you exit would be pointing to null. Make that point to new node, and anyway new node's link part I have set it to null, which becomes the last node in the list. So let us apply the same thing on this diagram. This is an already existing list. How many nodes I have? I have 4 nodes in the list. The first node is wherein the information part is 67 and the link part is pointing to the next node, and then the link part of the next node is pointing to this one, and the last node's link part is pointing to null. That is how I know this is the last node. Head is pointing to the first node in the list. So this is a link list which is already existing. Fine, this is an existing one. So what I have to do is I have to attach this new node which I have created and then to the existing list, and I have to make this or insert this as the last node in the list. When will it become last node? When this node, which is at present the last node of the list, point to the new node, then this becomes the last node in the list. Correct? So what I have to do? See, the first step is create a node and store its address. I have done that. Copy the information of the new node in the information part. Set the contents of the new node to the null. Have I done that? The information part is 100, new node is this one, and the link part is null. And there is no connection between the list as well as the new node. They are totally independent. The new node is this one, and this is an already existing list. After that, what I have to do? What did I do? Initialize head to current pointer. So I made current pointer is equal to head. So where is head pointing to? Head pointing here. So where should current pointer point to? The current pointer should also point to where head is pointing, right? Because I said current pointer is equal to head. 1 minute. So it is pointing here, right? To begin with, current pointer, I made it point to head because head also is pointing to the first node. Current pointer also obviously will point to the first node. So after that, what am I doing? While the link of current pointer is not equal to null, do current pointer is equal to link of current pointer, right? I need to first I did this step is done, step 4 is done now. That is current pointer is equal to head is pointing to the first node. So current pointer will also be pointing to the first node. Then I have a while loop in step 5 which will say that I need to traverse the list until the current pointer link part becomes null. Till that time, how do you traverse? Current pointer is equal to link of current pointer. Okay. So first time while entering the while, it will check whether the link of current pointer is null. No, the link of current pointer is not null. It will go inside the loop. What am I doing? Current pointer is equal to link of current pointer. So what is the link of current pointer pointing to? See, current pointer is pointing to this node. The link of current pointer is nothing but the link of this node. Where is it pointing to? It is pointing to this node, right? So I need to take this out, and then current pointer would point to the here. Yeah, current pointer should point here. After that, what am I doing? The thing is, it will go back check the statement of the header of the while loop, which will say link of current pointer is not null. Link of current pointer, is it pointing to null? No, it is pointing to this node. So it will go back, it will go inside the while, and then what it will do? It will make the link of current pointer is equal to null, right? Link of current pointer. Current pointer is nothing but link of current pointer. So where is the current pointer's link pointing to? It is pointing here. So it will be here. Now again it will go back to the header of the while loop. What is there? Current until the link of current pointer is not null. Is the link of current pointer pointing to null over here? No, it is pointing to this node. So again the while loop gets executed. Yes or no? In while loop, what do I have? Current pointer is equal to link of current pointer. So what is the link of current pointer pointing to? It is pointing to this node. Correct? After that, what happens? It will go back to the while header. So until the link of current pointer is not pointing to null. Where is the link of current pointer pointing here? It is pointing to null. So it will go out of the loop. Once it control goes out of the loop, where is the current pointer pointing to? Definitely it is pointing to the last node. Did you get it? First current pointer was pointing here to this node. Current pointer was pointing to, and I said the link of head is equal to current pointer. It was pointing to this node. Then the while it will next is the while loop, while the link of current pointer is not null. What is the link of current pointer pointing to? The link of current pointer is pointing to this node because it is not null. So it will go inside and then again it will check the same way link of current pointer goes on traversing until you reach the last node. In the last node, when now the current pointer pointing here and the link of current pointer becomes null, it goes out of the while. Once it goes out of the while, the current pointer would be pointing to the last node in the list. After that, what I have to do? So hopefully I have understood the while loop. After that, link of current pointer is equal to new node. That is what I have to do. Where is the link of current pointer? Here. So what it should do? The link of current pointer, instead of null, it should point to the new node. Where is the new node? The new node is here. See. The new node is pointing here and the new node's link part is pointing to null. This is how it works. Hopefully you have understood this. And this link is null. Is there? The link of the new node is null. The link of this node points here because current pointer is currently pointing here. This is how the traversal happens and you go and attach it to the last node in the list. Hopefully you have understood that. Let us write a code module, that is a function to insert a node at the end of the linked list. please make a note, a function to insert a node at the end of the linked list. How do I do that? First thing is function void I will give this name insert end int element, or since in the algorithm I have element only, let me say. So first thing what I have to know, I have to declare the data like new node and the current pointer, right? Because I'll be using two pointers here and head is already declared. So I need not declare because head is already pointing to the first node in the existing list. Node star comma star. Why is it? Both are pointers which points to a node. That is why I'm having two pointers over here. First one is to create a new node. Second one is to traverse the existing link list. So now I need to dynamically allocate memory to it. New node is equal to new node. That is, that many bytes of memory would be allocated. After that, what I have to do? I have to store the information part of the new node. Info is equal to element, right? Whatever the user enters, and then set the link part of the new node to null. Link is equal to, after that I need to traverse the list till I reach the last one. So I have to start from the first to the last, and I would be using the current pointer for traversing that. So I should start from the first. That is why I will say is equal to, because head is a node which is pointing to the first node. I am not declaring head here because head is already pointing to the first node. I would have declared that in the program. This is just the function. So double declarations I will not be doing there. After that, I should have a loop while current pointer link is not equal to null. See here, the initialization statement, that is current pointer is equal to head. Please don't write it in the while, because if you write it in while, it goes to an infinite loop, because every iteration of the loop, current pointer gets reinitialized to head, and then it never, like, you cannot traverse it, because every time it starts from the first, and then there will be, it will never reach the end, and there will be no exit, the exit condition will not be satisfied, and it goes to an infinite loop. Always in a while loop, you should be careful that the initialization condition should be always before the out of the loop and before it, and then the increment or the decrement should happen inside the loop. Otherwise, again, it will not reach the exit condition. So how do I traverse the loop? Current pointer is equal to the link of current pointer. Then this is the end of my while. After that, I should say current pointer. Once it exits the control, exits the while loop, the current pointer would be in the last node. So I have to just make the link part of the last node, which is pointing to null. Instead of null, it should point to the new node, so that the new node gets attached in the end of the list. Current pointer link is equal to new node, and I will be closing my, okay, let me close the function over here itself. So this is the code module for inserting a node at the end. That is, first I have two pointers because one is for traversal and one is for creating dynamically creating a new node. Once I create a new node, then after that I store the information part of that, and then I make the link part to null. Starting from the head, I traverse the list using the current pointer until the link of the current pointer becomes null. Once it becomes null, you would have reached the last node in the list. Come out of it and make the link of the last node point to the new node. This is how you write it. Hopefully you have noted down. So this is what we did. Like, see, now we traverse the link and we traverse the list, and then the link of this last node is pointing to the new node, and new node's link is null. This is what we did when we are inserting a node. It's the last new node as the last node. Now to insert a node at a given position. So what is the position of this node? It is 1, this is 2, 3, 4 and then 5. There are totally 5 nodes in the list. For example, I have created a new node and I want to insert it as the third node. So insert at the position 3. So what should I do? Like this node, instead of, this is the second node, instead of pointing to this node, it has to point to the new node, and the new node in turn should point to this node, right? Because this should point here and then this should point, the new node should point to the next node. So this will become the existing third node, will become the fourth node, and the new node will become the third node. That is what it means. That is, at a given position means if I want to insert anywhere in the middle, like here, if I want to insert, like after this node, I want the new node to be there, and then after the new node, this node would continue. So in between these two, I want to insert. Then what should I do? I should make this node point to the new node, right? And the new node point to this node. So automatically it comes in between the two. That is what is insertion of an element at a given position. First, we will write the algorithm and then I will explain you the algorithm with this. We will write the code later. Please write down the statement of it. Algorithm insert a node at a given position. At a given position. Algorithm, what would be the statement of the algorithm? Let list be a list stored in memory, be a let list be a list stored in memory. Head gives the address of the first node. Okay, address of the first node. This algorithm inserts item into the list at the given position POS. This inserts item into the list at the position POS. Current pointer is a pointer which is pointing to the current node of the list. See here, the thing is, if you want to insert, not in the, make it as the first node, that is the beginning or the end of the list, anywhere in between, then you need to ask the user to enter the position. This is not like array subscript. It starts from 1 to n. Like first node is first node, second, third, fourth, like that it goes on. Let the list be stored in memory. Head gives the address of the first node. So head is a pointer which would be pointing to the first node of the list. This algorithm inserts an item or a new node into the list at the position POS. That is, position is given by the user. You will ask the user to enter the position in which he wants to insert the node. And then current pointer is used for traversal, that is, it is used for pointing to the current node in the list. And one more thing you have to take care is, for example, I have only 5 nodes and you want to insert it as a 8th node. It is not possible. So it should not go out of range also. It should be a valid position that you need to take care when you are trying to insert an element. When you are inserting an element at a given position, you should check that many nodes, that is, it's a valid position. If you are trying to and insert it as in a position which does not exist, like if you are trying to insert it in 6th position where the total number of nodes itself is 4, then it should give you error. So that is the thing, you have to check whether it's a valid position entered by the user or not. And if the position, like until you encounter, by the time you encounter the position you're already end of list, then it goes out of range, right? Then you need to specify to the user or print a message to the user that position out of range. Otherwise, if it's a valid position, you should be able to insert a node at that position. Like if I want to insert a node at the position 3, I need to make the node at position 2 point to the new node and the new node point to the node at present which is there in position 3. So that will be pushed to position 4 and this gets inserted as the third node in the list. Getting it? Please will write the algorithm, write it down along with me. Then I will explain the algorithm with the picture. Then we can continue with the program, that is the code for inserting an element at a given position or inserting a node or an item at a given position. So how do I start with an algorithm? Like as always, I need to create a new node and store it in the pointer new node, write in the information part and make the, then after that I am not going to do anything with the link part. I need to make the link part point to the next positions, whatever position you want that node, the new node should point. So it's not going to point to null. Only when you're adding the node in the end, you have to make it point to null, or when you're creating a linked list, automatically would be appending the nodes one after the other. That time you will make it as null. When it's the first node, you will make it as pointing to head, and then head point to new node. Here what I am going to do, here I am not going to make it to null. I will point it to the node which at present is there in that position, and the previous node, whatever is there in the position, will point to the new node. So automatically this gets inserted in the new location. So let us start. Step 1. What I am going to do, create a new node and store its address in the pointer new node. Fine. How do I do that? New node is equal to fine. Create a new node and store its address in the pointer new node. I'm going to create it an address of the new node. Fine. After that, copy the what am I doing? Copy the information part of the new node to the copy the information for the new node to the information part. Copy the information of node to so info of new node is equal to element. I created a new node and I copied the information part into that. That is, new node is equal to address of new node. After that, what am I going to do? Step 3. Okay, you have already taken in the position from the user. So you are not going to ask here, because in the list, in the statement of the algorithm itself, I have mentioned that it would be inserting the element at the position POS. So it's already there. Initialize the head to current pointer, because I need to traverse the list till I reach the position, right? One before the position. So for traversal, I need current pointer starting from the first node. Initialize the head to current pointer. So current pointer is equal to head. After that, what I have to do? Move to the required position, right? So how will I move to the required position? I will say for, it's a loop, right? I know how many times I'm going to iterate. You can, there also you can use while, for, it's not, because I know till the end of that I would be going. For I, I'll say I is equal to 1, first node, to POS minus 1, 1 before the position. That is, if the position is 3, you have to stop at 2, because the node at 2 should point to the new node, then only it becomes a third node, right? And this new node should point to the node of which at present third node, so it becomes the fourth node. And current pointer is not equal to null, because to reach the position, and it should not be the last node also. Like if you reach the last node before, then there is no point, because position is wrong. Do, what will I do? Move the current pointer to the next node. Step 5, move the to the how will I move it? Current pointer is equal to link of current pointer. Right? And then if, after that I will just move it, for will end over here. Then if I have to check, that is, check whether the position is found or not. Check how I will do it. If current pointer is equal to null, print position out of range. Right? Print otherwise, what will I do? If this is not true, that is, if the position is a valid position. Else, insert the new node at the required position, right? How will I do that? Link of new node is equal to link of current pointer. Link of current pointer is equal to new node. So this is how you are going to insert a node at the given position. That is what you are going to do. First you are going to create a node. After that you are going to copy the information part of the new node, right? And then I'm not going to do anything with the link part over here. Initialize the head to current pointer. Current pointer is equal to head. Move the current pointer to the required location. I'm going to move it from first to the position -1 location. If the position is 3, I will stop the current pointer at location 2 only, because in the position 3 means the node at the position 3, the one to which the node 2 is pointing to, should be in the location 4, so that the new node becomes to location 3, correct? So move to the required position, that is 1 to position -1, and in the meantime I will also check that it is a valid position, that is if it is null then it goes out of range, right? If both of this is true, that is, it's a valid position, the current pointer's link, that is, you have not yet encountered the last node, and then you go till from 1 to position -1, move the current pointer to the next node, and then current pointer, how do you traverse? Current pointer is equal to the link of the current pointer, which would be pointing to the next node in the list. After that, once if it is not out of range, if current pointer is null, it will say position out of range. If the position is not out of range, what I'll do, I'll insert the new node at the required position. Link of new node is equal to link of current pointer. So suppose the position is 3, I have stopped. Where is the current pointer pointing to? Position -1 node, that is the second node. So link of new node is equal to link of current pointer. Where is current pointer? The second node is pointing to the third node. So now the new node link will also point to the third node, and then this is link not. Link of current pointer, that is which is pointing to the third node, that is node number 2, because that is equal to new node. So link of current pointer is nothing but the current pointer is in node 2, that will point to the new node, and the new node would be pointing to the at present link of new current pointer. Getting it? So please understand, try to understand this, and in next class I will explain you with the diagram, as well as we will do the function to insert a node at a given position. Hopefully you have understood this. Please make a note. Now the homework question. write an algorithm to create a linked list. Okay, hopefully you've understood today's class. Take care, stay safe. See you tomorrow. Bye bye.